way in which fish feed is something that is related to the way other fish feed. Certain organisms will feed in certain ways and others in other ways. How can then the predator population suddenly increase? Now, very quickly, the usual suspects are turned to, and I'm wondering whether the fishermen who are sometimes claimed to be the problem are not actually the victims here. There are, in any way, many factors that play into this. For example, the use of seaways and the number of offshore installations is also something that needs to be seen in this context. So, in the first part of this seminar, we're going to look together with our experts at a number of issues, such as what is the relationship between predators and prey in the food chain? What sort of interactions are there between organisms that are of importance? What influence does the availability of food have on the structure of these networks of feeding chains? And what environmental parameters and economic interests, which of those need to be taken into account as well? In the second part of this event, we're going to look to try and thrash out some solutions, some possible ways forward. We need to look at long-term viable approaches. Also, it's important to look to a super-regional level and a Europe-wide level, because what's the point of us having a plan to regulate the cormorant in German waters if this is quite happy to go over the border to Poland and eat all the fish there and thereby proliferate? After this seminar, I'd like to invite you all to a reception outside this room where we can maybe go into a little more depth in the knowledge that we've gained. And first of all, I'd like to give the floor to Mrs. Damanaki, who is the Commissioner responsible for Fisheries and Maritime Affairs, who was very kind enough to accept our invitation to come here and speak. She's going to give us the perspective of the Commission. You have the floor.
Mrs. Reimers, Mr. Gallagher, honourable members of the Parliament, ladies and gentlemen, I'm really pleased that you have invited me here today to discuss with you the challenges to the marine food chain. I guess we can all agree that the marine ecosystem, and particularly the food web, is a very sensitive system that needs to be protected by all means. Changes to the food chain by diminishing or removing one key factor will damage the whole structure. So, predators and fish, as Britta already mentioned, they have a special relationship between them in the nature. So, we have to keep it and study it in the most cautious way. Later this afternoon, I believe we will hear from scientists about the essential factors of the food web and the reasons for marine imbalances. It is known today that besides the big problem of overfishing, also other factors like climate change, environmental or economic causes can influence the balance. In this regard, our scientists have to give us full and accurate data so that they can make full and accurate assessments. Moreover, they need to take all impacts on the food chain into account. Scientists are working on this, and I encourage their work. Better science will result in better advice, and this will result in better decision-making and resource management. This is my general position. As Commissioner for Maritime Affairs and Fisheries and in charge of the Common Fisheries Reform, however, let me address today preliminary the issue of overfishing. I think this is our main concern. This is the most urgent problem I am facing in my mandate in the Commission. Today's marine management, as it stands, cannot face the overcapacity in our fleet, nor can face an old-fashioned top-down approach that does not give sufficient responsibility and ownership to the industry. What is the result? That 88% of our fish stocks are overexploited. No wonder our marine resources are in bad shape. As I have already said on many occasions in this House and elsewhere, this situation simply will not do. Nor will changing a few screws here and there and calling it a reform. This is not an option. We need to modernize the common fisheries policy from the roots. The reform must bring about a new way of fishing that delivers sustainability to our plates. In other words, the reform must bring about an ecosystem approach to fisheries management. I believe that if we get it right, this will mark a substantial step forward in preserving the marine food chain. In this context, ladies and gentlemen, it is important to point out that there is the way we fish, and then there is the way we buy. The consumption habits and consumer behavior are inevitably linked to the marine food chain. Let me therefore today to focus as well on the way we buy, on the way the fishing industry and the retailers cooperate, and on the choices made by us, the consumers. The EU is the first market for fish products, as our consumers spend 55 million euros every year in buying fish. 55 million euros every year. This shows that there is a fundamental market dimension to sustainability. This market dimension, which involves producers, but also operators and above all consumers, can complement our conservation efforts. Therefore, we are looking now at a new market policy as an important part of the new reformed common fisheries policy. This new market policy will support fishermen in selling sustainable products. The golden rule here is clear. The fish which cannot be sold at a fair price is best left in the sea. This new market policy will also help the fishing sector organize itself more efficiently. We need to help the fishing industry and the aquaculture industry to organize production in an efficient manner, to take a real role in the day-to-day implementation of a reformed common fisheries policy. We need to give them more say in how to manage fishing activities and in when best to put their products on the market. We also need to help fishermen get organized better so that they have a better economic standing vis-à-vis the retailers and can get fair prices for their products. And finally, helping them to support marketing actions for their products is another concrete action we should take. I was very pleased to see in this regard that initiatives are already taken in the different member states. We have to see the positive examples we have here. We have positive examples. For example, I would like to mention the Institute for Baltic Sea Fisheries in Germany, which feeds information on the state of different fish stocks to a website. This information is not commented, but helps the consumers, trading companies, and processing businesses to inform themselves. It helps them to adapt their buying policy on the basis of exact scientific information. I believe there are similar ventures in the United Kingdom and in France. Here we find the creation of a useful linkage between the fishermen, the processors, the retailers, and the consumers. As for consumers, the new market policy should provide them with additional tools to make an informed choice. Today, citizens are more and more aware of the challenges the marine resources are facing. They want to know, and they ask, is this fish fresh or defrosted? Where exactly was it fished or produced? Was it fished or produced sustainably or traded fairly? These are questions people ask. Good labeling initiatives are the answers to these questions. Each purchase can contribute to sustainable consumption. People are entitled to that information. It is our duty to make this information accurate and exhaustive so that consumers become the main driving force of sustainability. Actually, this is already a trend in some countries. There, major processors and retailers, such as big supermarket chains, are more and more buying their products from sustainable resources. The United Kingdom retailer Sainsbury's now sells more than 50 fish products from sustainable sources. But also for Germany's EDICA products, sustainability is high on the agenda. They have pledged that by 2012, all fish in their supermarkets will be from sustainable sources. This is very, very important. This phenomenon has also spread to France, where Carrefour is promoting sustainable fish on its shelves. This kind of market development could change the supply choices of EU operators for good. We still do our part to promote it all over Europe, but supporting dialogue and cooperation is our main aim. We need this dialogue between the fishing industry and the retailers. But when talking about sustainable fish, I believe it's only a question of time before consumers want to know how much fish was thrown dead back into the sea, just in order to catch the fish that ends up on their dinner plates. Therefore, we must also find a way of ending this wasteful practice of discarding fish. Ladies and gentlemen, I tried to outline how a new market policy can contribute to conservation and how the proper market mechanism can multiply our efforts. The shift towards sustainability requires a shift in attitude and the right choices from the consumers. Fish stocks constitute a shared resource for which we all share a collective responsibility. We must convince everyone, from fishermen to consumers, that we'd better all make an effort to save this resource. Fish is the bread and butter of a resilient fishing sector and thriving coastal communities. So, I understand that there is more to an imbalanced marine food chain than overfishing, and I support the scientific work to get us exact and workable data. That's why I'm here. Nevertheless, let me stress again that overfishing is my biggest challenge as a commissioner at the moment. The reform has to do something concrete about it. Thank you for your attention.
Vielen Dank.
Thank you very much, Mrs. Damanaki, for that very interesting presentation. You touched on some important points. We really have to look into research more and get all the stakeholders around one table. So thank you for that. The food network is a living system which is in trouble in many different places. Now, research is something that we'll be dealing with in the first part of this seminar. We've got two excellent experts with us, Mr. Neuenfeld from the Technical University of Denmark, the Institute of Aquatic Resources. He is a biologist and a research scientist for his institutes, and he deals with research and looks at fish stocks and the relationship with predators. You have the floor, sir.
Ja, vielen Dank, Frau Reimers.
Thank you very much, Mrs. Reimers. Marine food chains something that we've known about since the 13th century, and scientists have used them for inspiration for many years. You can see this illustration from Peter Bruegel in the Middle Ages, and one of the main points that came up then was that the big eat the small. Big fish eat little fish. Species interactions and the balance of marine food chains. My name is Stefan Neuenfeld. I'm a research scientist at the Technical University of Denmark, and I'm also a coordinator of the EU co-funded project FACTS, Fish Interactions, a Fish Interactions project. Now, this is a slightly more modern illustration of the illustration that I showed you first. This is a simplified illustration of an ecosystem where you have the different elements, the plankton, which eat. Then you have the forage fish, which relatively central in the food chain. Then you have piscivores as well. Then you also have seabirds and fisheries as well. Unfortunately, the light's not very good, so you can't see this very well. But in the top left, you have the climate and the different influences on the food chain. I'd like to thank the Commission for helping our research under the 7th Framework Programme. Now let's look a bit more closely at the marine food chain. So we have phytoplankton right at the bottom. They eat mini plants. And this is the first step of the food chain. Energy is transformed into food. They are the primary producers. They are the start, if you like. And there's one level up from this. You have the zooplankton. These are animals that can photosynthesize. They exist by eating smaller organisms. Then we go up to the top predators, and you have seabirds and humans. In between, you have piscivores, such as cod, Baltic Sea cod. They're the most prominent examples. And then between them, you have the fish we eat and the top predators. There are some 15,000 types of zooplankton, thousands of types of forage fish, many types of piscivorous fish and predators as well. Now, why should we really study this? What's so interesting, apart from the purely academic? Well, an ecosystem contains many different elements: water, dead animal particles, lots of different species of organisms, bacteria, phytoplankton, zooplankton, forage fish. Now, all of these organisms influence each other and are influenced by the environment around them as well. And what this means is that we can influence them. So whenever we intervene in this system, there is a high probability that we're not only going to affect the targeted species, such as the cod that we might be trying to target, but other species as well. Well, is that important? Does it really count? Well, here are some examples. For the Baltic Sea, from 1975 to 2005, and then for the North Sea, from the 1960s to the current era. And here you have the some 6,000 tons per year of biomass. So this is the fish biomass that's eaten by other fish every year. So if the effects are relatively the same, so they're of the same magnitude, if you like. So in the Baltic, fisheries and the biomass that's eaten by fish is more or less the same, and the same is true for the North Sea. In the North Sea, more fish are eaten by other fish than are caught by fisheries. But in the two areas, you see that there's no marginal effect here on the ecosystem. Food chains have another function as well. It's not only that fish eat other fish, but fish eat the food of other fish. So there's competition. In the Baltic, on the x-axis, you'll see the size of the sprat stock. On the y-axis, you have the condition of the herring. Now, you might ask how much a herring weighs, a centimetre. So what does a herring weigh? And what you'll see is actually the bigger a sprat is, the smaller a herring is. So sprats are eating herring's food, the phytoplankton. So we have this allows us to understand the effects and the variations. Now we've seen the marine food chain, and now the question might arise, well, we might ask who's checking on it, and what are the balances, checks and balances within the food chain. If you want to categorize it, there are three different explanations you can take. The first is the bottom-up control. So you have phytoplankton, which are the lowest level of the chain. They're influenced by the climate, and the phytoplankton influence the availability of food for zooplankton, and zooplankton then influence availability of food for small fish, and that the quantity of the small fish does then impact on the availability of food for other fish, and obviously the growth of predators. So that's the bottom-up approach. Then you have the opposite with the top-down approach. There you see that there are so many phytoplankton that's not really a problem, but the problem is with the top predators, and how many small fish they eat, and then how many zooplankton are eaten by the smaller fish. And then you have the mixed scheme, the wasp waste, where there's a bottleneck around the small fish. The frequency of these fish affects both the top and bottom levels of the food chain. So the question is, what impact does this have? Is it an impact on the hunters, the predators, or on the food itself? The case is that the different control mechanisms have different effects. On the left, you'll see the bottom-up control. So when there are fewer phytoplankton, that means less food for zooplankton, so less plant material, and then that leads to fewer forage fish and fewer predators. So there's a signal there of what's going on at the bottom of the chain, and this has an impact all the way up the chain. So that's really indicative of a bottom-up control. An example now from the North Sea, where you see a declining trend for phytoplankton, then the same for zooplankton, then the same for herring, which spread to declining numbers in kitty whales. They then laid their eggs later, and there were fewer offspring, fewer chicks. So the same direction with all these trends with the bottom-up control. Then when we move to the opposite with the larger animals affecting the smaller through climate, through the influence of climate, when there are fewer predators, then that means that there are more forage fish. But the increase in small fish means that there's less food for the zooplankton, so fewer zooplankton, and that means more phytoplankton. So in the top-down control, you see the opposite picture to the bottom-up control, where everything was heading in the same direction. There are examples of this in Alaska with killer whales, which eat otters, and then what we saw here is that when there were fewer killer whales, this also had an influence on sea eagles as well. And sea eagles were a very important management objective in this area. And sorry, on anemones in this area, and that really is indicative of top-down control. And then the last one, the last situation we have is the wasp waste control, where there's this bottleneck of food. This is often seen in coastal areas where you have a decrease in the number of forage fish. What this means, if you have a lot of these fish, these forage fish, then you'll see more predators coming in because there's more food for them. But this also then has a knock-on effect on the zooplankton and the phytoplankton. So you get both directions on the graphs, where you have this bottleneck with the forage fish. An example is in South Africa, where you see the occurrence of the numbers of penguins, and their numbers increase with the numbers of sardines. But then that has a knock-on effect on the bottom or the lower levels in the food chain. So the question is, well, which one is it? Are we dealing with bottom-up, top-down, or both? And really the answer is no one really knows. We know that the environment does have a huge role to play. We also know that controls through predators, large fish, keep fish numbers down. because if there were no predators, then forage fish would reproduce in a virtually uncontrolled fashion. So the top-down control stops this from happening. This wasp-based control, the bottleneck, then you see these massive increases in forage fish are actually controlled by climate factors. Often, these control ideas are concepts, of course, and they have a lesser or greater effect depending on the environment. The question is now, what purpose does this all serve? Here you have a headline from Nature in 2008 from Bob May and Simon Levin. And you'll see here it says ecology for bankers, and we're not talking about that bringing ecology into the euro area, eurozone, but here the rules that are used in the banking system are very similar to the rules that apply to ecology, but of course the data is much better in the banking system. You have fantastic data there, and I think they really hit the nail on the head there with this title. Obviously you have to identify the different relationships in a system where you have a good that is apparently in a good situation and then ends up in a bad situation. You have to realize and try and preempt what's going on. So you need to look at the interactions. How can you translate that into biology, though? This is based on Koster and Omer's work, this slide, and it reflects the situation in the Baltic. Here we have cod. They lay eggs, they turn into larvae, and then the larvae become cod. Up till 1975, there was what we saw is that stocks up until 75 were able to replace themselves, but since then that's not been the case. What the consequences of this have been is that the high levels of high stocks of cod have been decimated, which has had a consequence with on sprats, and there have been more and more sprats. And the twist in this story is that sprats are actually predators on cod eggs. So here you have the prey at the same time acting as a predator on another stock, that is to say the eggs of the original predator. So the increased numbers of sprats impacted on the number of cod eggs, which meant fewer cod eggs and fewer cod larvae and fewer cod. So it's a circle. It's not a case of just being having fewer cod, but also fewer sprats and a new situation, which was hard to forecast or impossible to forecast beforehand. Obviously now the question is, why quantify this? We understand the qualitative part, but we don't know the dimensions, the quantities. We don't know how many tons of sprat are eaten by cod. And obviously that's a problem. We have to get past just realizing what the problem is and then look at the scale of it. Because only then can we really answer what the significance of removing a fish or what climate changes will bring to the food chain. For instance, if the Baltic Sea warms, what will happen to fish? Well, it means that there will be a 50% cut in cod stocks? I mean, what does it mean? And perhaps even more importantly, are there key species that need to be managed very particularly to keep the ecosystem as we would like it to remain? And they can only be answered, these questions, by quantifying the processes. I'm not going to look at the mathematical relationships with the stocks, but I'd like to give you a few illustrations of how we can measure and quantify these processes. If you look at this question, how to quantify the effect of human actions on marine ecosystems. Now, the first step is obviously operational questions. So firstly, we have to think about how many and which prey organisms are consumed by which predators per unit of time. So that is measurable. So you have a predator here. So we try and work out the volume of our search. So these are all factors where we try and quantify the amounts in question. Then we try and work out when these swim through our through the area we're searching. We try and work out what the prey, what prey they predate on. So what the effects would be on those. And as you can see, we're on quite a specific level here, logically and technically as well. We have to work out what the processes are and what the order of magnitude is of these fluctuations in the food chain. So we're looking beyond the qualitative. We're looking to see what the quantitative changes would be. A lot of research is going into that, and some projects have already been carried out. For instance, there was a large EU project in all the North Sea areas where cod were electronically tagged, so we could identify migration patterns and also other relationships. This EU project gave us a lot of data, and it will take a year or so's work to process all this data. At the same time, we're carrying out acoustic surveys with the help of the Commission as well. And at 90 meters depth in the Baltic, we looked at herring and sprot schools of fish, and trying to look at the distribution of the fish within the area we were searching. And then last but not least, we're working on crime scene investigations, if you like, because here what you'll see, you have a cod that ate 3 eels. So Niels Andersen, my colleague, is working on this, and we can work out when these organisms were eaten. So that gives us an idea of the relationship between predator and prey, and to give us an overall view. That gives us an idea of the status of the stocks and interactions in the food chain. Now, to summarize, species interactions do affect the productivity of ecosystems. The balance of a food chain or ecosystem does depend on the control mechanisms that exist. We have to understand the control mechanisms to understand changes and to interpret these changes in the ecosystem and food chain. And last but not least as well, we need to be able to identify what is predictable and what is chaos. We know that, for instance, if a leaf falls off a tree, we know the forces that are enacted on it, but we don't know where it's going to land. And that's something that could feed into this kind of system. There are things that are just not predictable. So we have to be very cautious in how we choose what methods we're going to use. To have this type of mechanistic understanding, we have to have an individual-based form of knowledge and collect data that is based on the individual. You can't just collect data and then compute it all. You have to work it out on the individual level. Thank you very much.
Vielen Dank.
Thank you very much. That was extremely enlightening, and I think the information you gave us there was very useful, Dr. Neuenfeld. I'm sure there's a lot we can link into what you've just said. Now, before I open the floor for questions, I've got a question. Here in Parliament, we work together with colleagues from many different countries. We try and work towards consensus and understanding, but of course, national preferences sometimes get in the way of that consensus. We try and bring on board then people from other cultures and countries. What's your experience in working together with others to learn more about fisheries? So that's my question to you. After that, we can then field some questions from the floor.
Meine Erfahrung
Well, my experience as the leader of the current project and also as the case study coordinator and a leader on a number of other projects as well, is that research within the European Commission and the research that is supported by the European Commission is not characterized by national interests. And I think the reason for this is that first and foremost, we want to work out how these systems actually work. The scientists that I work together with try to avoid the interpretation stage before they've actually gone through the comprehension stage. So it's just a question of being curious. Thank you very much. Are there any other questions from the audience? No? Okay. Well, thank you very much, Dr. Neuenfeld. Moving on now to our second speaker, Dr. Gerd Kraus. He is the director of the VTI Institute of Sea Fisheries and Fishery Ecology in Hamburg. Dr. Kraus will be talking about how short-term variability and long-term changes in the marine food web affect the ecosystem-driven management. He can give us some answers on how we should be organizing this sort of thing. You have the floor, sir.
Ja, meine sehr verehrten Damen und Herren.
Thank you very much, ladies and gentlemen. Thank you to the host for inviting me to speak here. I'm very pleased to be able to take the floor here and to tell you about something that's a hobby of mine, a passion of mine. In the following 15 or 20 minutes, what I'm going to try and do is try and sketch out the mechanisms, how these sea and marine ecosystems change. I'd like to go into a little more depth about that, but also I'd like to draw attention to the management implications of these changes, that what they bring about, what's essential. And then the next session, I think I'll have paved the way for those discussions. So why do we talk about marine food webs? Well, for fisheries management, it's extremely important. Since 2002, we've had the World Summit on Sustainable Development, and we have the term of maximum sustainable yield. That is the main guiding line that we have. It's an old concept. It's a concept in the 50s of the last century. Mr. Graham and Schaefer developed this idea. It's a very theoretical model for calculation of what, in theory, tells us that the maximum sustainable yield would be and how much biomass can be taken out of that without damaging the stock. You can see there on the curve what that all means. So we've seen the collapse of stocks in the past, and that's why these sort of approaches have been looked at and turned to. I can give you a quote from Mr. Gulland, the grand old man of marine biology. He was talking about the MSY project and what the objective should be. He said on MSY,
Been shown by biologists not to exist and by economists to be misleading if it did exist. And this is the key to modern fisheries management. Also war nicht.
So he wasn't over enthusiastic about the original concept. He pointed out there were weaknesses there. The weaknesses of what we have to call the traditional MSY concept is that ecosystems, of course, per se, are unreliable, incalculable. You know, you have things that change. You have the climates that come into effect as well. It's not just food chains. It's very complicated networks that we're talking about. And this traditional MSY concept doesn't actually take into consideration the other aspects of the environment that do have an effect on that. So we have the theory here. This is something you're going to probably see occasionally. This is a very simplified version of the herring food network, moving from phytoplankton and those sort of organisms to the forage fish that Dr. Neuenfeld mentioned. This is a very simplified network. It's extremely complicated. You see all the arrows there going all over the place. But if we then look at how these complicated networks function over time, then this is something that we look at very seldom. These systems are never very stable. They tend to fluctuate around a stable balance, if you like. You have that red line, which is the balance, and then the system and the individual system components, such as fish, fluctuate around that central line. So for current fisheries management, that's not really a problem. These fluctuations are normal, we're well aware of them, and the management threshold values that we use tend to be quite robust to deal with these usual fluctuations. There's certainly an amount of a buffer built into those. I can give you an example. There's a hypothetical stock. We've got the parent stock on the X, and on the Y we have the offspring as how many parents are needed to produce how many offspring or juveniles. And you plot all those points there. We've got the dotted line there on the right and see the fluctuations there. We can see that can be managed very well. You've got the buffer zone there, and the change will only come about where action has to be taken is much further on, so we don't really have a problem with that. However, we do have an era now where climate change does start to have an effect, and we can see over time that things are changing. It's not just fluctuation around a stable line, it's a gradual change, and these gradual changes generally can be managed through statistical methods. These sort of trends can even be covered by certain complex statistics. If you understand what's behind them, you can really see what's going on. And if you look at the management methods that are used, you can be proactive and really deal with the change, and that's not really a problem. But I've got a further example that I've brought along, North Sea herring. They have at the bottom the development, recruitment, the grey there, in relation to two climate indices. Those are the wavy lines, if you like, the dotted wavy lines. So it's not always easy to predict, but given the way those two have a relation on each other, you can extrapolate data to help out in predicting. But the biggest problem comes about when there's an abrupt change, very abrupt change, and this tends to be usual in certain ecosystems. When we talk about regime change in the literature of the science. It's a phrase that's used. The trouble is that this regime change is very difficult to manage because it is fairly impossible to predict, and in general there's a huge change in the usefulness of that stock, if you like. So how can we understand these changes? How can we turn the clock back? Can we change things around? I can give you an example from the Baltic once again. We've heard already, and on some of these aspects. At the end of my presentation, I'll come back to the management side. In principle, this sort of ecosystem can be described by a line with troughs and peaks. There we have the y-axis on the status of the environment, if you like, and on the x-axis the different forces and impetuses that have an effect on that. So we've got some troughs and some peaks. Stable are the troughs, unstable are the peaks, and that grey zone is where we would like to be, with the service provision there, with very valuable fish stocks, not a great deal of eutrophication, not a great deal of contamination. It's fairly stable peaks and troughs there. That's what we like to see in our ecosystem. That's the desirable state of affairs. If you look at overfishing and increasing eutrophication, a gradual climate change and contamination, global warming in general, that will mean that the peaks of these lines are flattened gradually, and that means the danger that this ecosystem turns into a state that is not desirable is very great. And if you look at the lack of influx in the Baltic or changes in tidal flows and other flows, those are the straws floating that have broken the camel's back, and that really brings us to a situation which is undesirable, where you may have a collapse in the network, where you don't have a great deal of valuable fish, where the quality of water is a problem, and the question is, how can we turn things around there? Well, in theory, there's an additional effect that we know from hysteresis, in fact, and here you can see how a typical ecosystem curve might look. You don't really have troughs and peaks. Really what you have is a situation where there has to be a very clear force that's exerted on it to change the whole system, to tip it, and to get it back to where we want to be, F2 on this. That's where the change took place. In general, it is not possible to get back to the desirable original state. There has to be a clear change in the external situations and conditions to actually get that back to the original situation. So once the system has been tipped, in general, it is impossible to return to the original state. I think that's something that needs to be borne in mind. That's maybe as much as I'm going to say by way of theory. We've talked about the Baltic with we've heard from Mr. Neuenfeld. So in the Baltic, we are seeing changes. In the end of the 80s, start of the 90s, we saw changes in a cod-dominated system to a sprat-dominated system. So are we looking at regime change there? Well, here on this slide you can see the relations there between cod and sprat over time. There's an anomaly from the median value for a long time, looking back to the the mid-70s and the 80s. Positive cod means negative sprout and vice versa. So that got turned around. Now, are we talking about regime shift or regime change? Well, if there is a regime shift, we're talking about a change in the whole of the ecosystem, and that's why I've given you this wonderful slide. You can't read anything, but you don't have to, because I'm going to explain. This is a traffic light graph. So you've got system variables here, number of sprat, cod, salinity, temperature, whatever is a variable there in the system. Then on the other axis, on the x-axis, once again we've got time from 1974 to 2006, and then the colours symbolize the status. Red is high or much, medium, and then low. So you can see certain trends that can be plotted there. If we look a little closer at this, you don't have to, because I'll explain what's hidden behind these trends. At the start of the 70s, we'd had a system where the variables such as a lot of herring and cod, we had pseudocalanus, a type of plankton, high salinity in the Baltic. Then in the medium area where the system was switching, dominated by a lot of food such as phytoplankton, and then in the upper part, the cod basically disappearing, everything's turning green there, and sprat, other forms of plankton are changing, which link into the sprat and other aspects there. So you can see there a very clear shift in the change of the ecosystem between 1974 and 2006. So it does appear that there has been a change on all levels that we are actually dealing with here. On this slide, basically there are three main variables that I've extracted. On the left you've got the environmental ones to look at temperature and salinity over time. In the middle, two very important plankton species that I've mentioned, pseudocalanus in red, which is very important for cod, and then acacia, which is important for sprat. And then on the right we look at the development of the stocks for cod and sprat, and the curves have been plotted in there, include productivity of the species concerned. Now what I'm trying to show you with these slides, if you look at the left there, at the beginning of the 90s, end of the 80s, we had a change there. It was very clear that the salinity reduced in the Baltic and it got a lot warmer in the Baltic. But we also see that around the change in the millennium, things started to change the other way again. Salinity increased, there was more influx and reduction in temperature. But what we don't see, and the two slides on the right actually do show this, is the biological component of plankton and fish didn't actually change back with the environmental changes that came. They shifted once, but they didn't shift back again, and yet it's meant to be a stable system. Now, Dr. Neufeld told us what the problem here is, that these sprat eat the eggs and larvae of the cod, and so they're eating what then would become cod, and that is very important, which means that the number of larvae cannot maintain the stock to reproductive levels as would be necessary. So there's a negative stabilization mechanism which has led to the hysteresis of this system. Some of those here who know about the Baltic know that since 2005 we've seen the cod miracle, that the cod stocks are recovering. In 2005 we saw there's a development there whereby many more cod were available. So as I say, at the end of the last millennium conditions changed, but we have seen that the reduction of sprat pressure has led to this. The sprat are moving further to the east in the Baltic. So it's not necessarily the environmental changes that brought about the changing in cod structure, but we think that there'll be a clear reduction in the fishing mortality in cod stocks. We've seen since 2005 a massive reduction in the mortality of fishing. We've got illegal landings, unrecorded landings as well. So this is something you can see it goes back to 1965 and 2008-09. That led to a real low point, which meant that the hysteresis of the system could possibly be changed, and that the balance could be reintroduced to turn the system around. To put this in a nutshell, important changes in marine ecosystems often happen quite abruptly and bring about new stable relations, and the only way to change things around is to change the whole system through a kind of shock, if you like, through, as we've seen in hysteresis. And you have the top-down trophic cascades, you have the bottom-up effects that come from productivity, or as we've heard about the hourglass or wasp waste approach. So what does that mean for considerably as well? That's something that management needs to take into consideration. The problem that still remains that is unresolved is that if their productivity changes, there's still no clear change that can see. I've got you a little example from the North Sea. This shows the MSY over time in terms of fishing mortality. You've got the red curve at the top of the slide. What you can see there is the drop in recruitment. If you include that and the fluctuations in growth, then this is not a stable value at all, which means our management decisions should be changed year on year, which confuses the issue. The second important point is the ecosystem objective that maybe we should set. We have a framework that is in place, but we haven't really taken it into consideration. Ecosystems are not really taking on board MSY and vice versa. If we want to do that, then I think it has to be, the MSY has to be part and parcel of an ecosystem-based management. You can't just have a one-size-fits-all for ecosystem or marine food chain management. And finally, I would just like to briefly tell you in conceptual terms how that could be done. One of our ecological experts is now here in the room. They've been thinking about how this sort of integrated management approach could be formed. Integrated management can only go hand in hand with an integrated assessment as a basis for that management system. And first and foremost, you need to be clear about the overriding goals and problems. Then you need to set out what the indicators are that you want to measure, and that's where MSY might come in for commercial fishing stocks. And then building on that, you have to think about the risk analysis of the different human activities and what aspect they play, what ramifications there are there. And then there are all sorts of modulations, different management strategies that could be brought in through various simulations and given an assessment, choose the best one, implement it. What's important there then is that the successes booked vis-à-vis the ecosystem developments need to be monitored and evaluated so we can see what the changes that might be necessary in the overriding goals or the indicators that need to be taken on board. So I'm sure there are many other concepts that other colleagues could mention, and I could, but I'll leave it at that for now. Thank you very much for your attention.
Thank you very much, Mr. Kraus. And now, given the comprehensiveness of the topic, you gave us a very clear presentation. We need some time to mull it over, I think. You told us about the changes in the ecosystem and what's happened and the dramatic consequences that they can have, but you also showed, in your opinion, how we can react to these changes. I'd now like to give the audience the opportunity to ask any questions, and I have a comment myself, actually. We saw that you've seen that the commercial fishing is an important part and has an important part to play. So when there's a fluctuation in the ecosystem, there's a parallel, i.e. that we have to react, and that's something that we have to bear in mind. We have to react earlier on in the day than before so that we can keep the food chain in balance or in check. And that's something that I found particularly of concern. Now, does anyone have any questions that they'd like to ask?
Ja, bitte.
Yes, please, sir.
Ja, schönen Dank.
Thank you very much, Jens Menneke. Represent Lower Saxony. I have a question from the presentation that Mrs. Damanaki mentioned, that a lot of data has to be collected, and that came in the presentations as well. Now, there's less and less in the way of finance available for this as budgets are being cut. So where is this data going to come from? And how's it going to be paid for? are fishermen going to have to bear the costs? Are they then going to have to pass these on to consumers? So how does this fit in with fishermen and secure investments for them? Well, a very justified question, I believe. We've implemented management systems at the moment that are very data intensive. If we have to come up with specific recommendations for quotas, then we have to rely on these systems. But if for financial reasons such data cannot be collected, we have to get used to management systems that are more robust, and that means that we have to be more careful with the systems and more careful as well with what we're doing. So we have to be more careful and be more careful with our recommendations. Otherwise we'll never get out of this dilemma, I believe.
Ja, eine Frage an Herrn Kraus.
Nina Wolf from German Environment Aid and for Action 2020. Now, 2012, sorry. Now, you mentioned this concept. As a scientist, as a government scientist, do you think that the government should base its work on MSY or not? What would the consequences be? Well, MSY, as originally designed, is not suitable for managing fish stocks or ecosystems. I presented what ISIS came up with, and I'm sure the Vice President of ISIS could speak on this. It can act as a sensible basis, but from an operational point of view, we need a better concept for MSY. The traditional interpretation of MSY is something that we need to step away from. With MSY, we're trying to create options whereby we can have these yields without damaging the system. If you look at the threshold values and so on and so forth, that's all a matter for scientific debate. Now, really, this could be part of the puzzle, really. But it's not the be-all and end-all with management. There are components that have to be fed into the management of ecosystems. So we need a broader interpretation of MSY, and that could help us with managing fish stocks. But also we have to bear in mind the other aspects. Now, I don't want to demonize it as such, but the traditional understanding of the concept has to change. Thank you very much. Any further questions? If not, I'd like to turn to Mr. Gallagher now, and he will moderate the second part of this meeting. Thank you.
Thank you very much, Britta. And at the outset, let me thank Britta Reimers for organising this. When my name is attached to it, the initiative is largely Britta, but we work very well together in our group and also as members of the Fishery Committee. And I want to thank her and her staff and all of the others who have been involved in arranging this. We have now concluded the marine food chain, exploring the reason for imbalances. We move on immediately to session 2, which is how to meet the new challenges. And we're very fortunate to have with us two eminent persons in the name of Dr. Paul Connolly, and after that we have Serge Michael Garcia. Paul, whom I've known very well from my years as a Marine Minister in Ireland. Paul is the Director of the Fisheries Science Services at our Marine Institute in Galway on the west coast of Ireland. Paul leads a team of 50 scientists engaged in the provision of scientific advice on living marine resources. He's currently the first Vice President of a very important body, the International Council for the Exploration of the Seas, and will become its President in 2013 to 2015. He also has chaired the reform group in ICES that revised the scientific advisory process to make it more transparent and, let us say, to make it fit for purpose. And of course, I know from my experience that he's a passionate advocate of the ecosystem approach. So I now give you Dr. Paul Connolly. Paul, you come over there.
Okay, thank you very much for inviting me here. I've entitled my talk, The Challenges of Change, and I'm going to tell you a story about what's happened in the 20th century to the oceans and fisheries. Then, at the point we're at now, to see the challenges we have to implement better management. What I'm going to bring you through is some background information, then talk about the concept of fishing down food chains, how the ocean has changed over the last 100 years, and then talk about the solutions in terms of management and what needs to input to management in terms of data, in terms of communicating with stakeholders, in terms of setting up area-based management plans, and then I'll say a few concluding remarks on meeting these new challenges. So the first part of my talk, some background information. In life, we have to wear many hats. And I wear two hats. I wear many hats. I wear a home hat. But the two hats I'll talk about today are the Marine Institute hat I wear, which as a director engaged in supervision and looking at the science of 70 scientific staff involved in data collection, assessment, a range of very broad issues concerned with the ocean. I'm also heavily involved in ICES, and as Pat said, I chaired the group which reformed the advice. But the hat I am wearing today is my Marine Institute hat, so what I say today is on the basis of being a director of the Marine Institute and not as an ICES vice president. What I'm about to say is also built on scientific experience I've had over the last 15 years, and they're based around data collection, about generating scientific advice, about working with stakeholders, about feeding research projects in and making them practically implemented, about reforming and changing when it needs to be changed, about working in Natura sites and how you have to develop plans where fisheries has to take on environmental considerations. And a huge thing that's happening in the policy of today's EU is the Marine Strategy Framework Directive, and I'll say a bit about that. And then on top of it all, it's how we implement the ecosystem approach. The European seafood industry is probably the end user of the marine food chain we're talking about today. It's a big business sector. It employs 141,000 people, 85,000 vessels, annual catches of 7.7 billion, production sector 23 billion. Community support for the fishery sector runs to 4.3 billion in terms of the EFF. The EU data collection framework, 57.2 million. Fisheries research, about 190 spent by the EU and member states. We have a large research vessel fleet, many research laboratories, many scientists, and that doesn't take into account control and enforcement. So we're dealing with a big sector and a big business. And I did a little exercise here. That 23 billion, where does it sit? It sits in the top fortune companies of the US, with Microsoft, Apple and Coca-Cola above it, and Google, McDonald's and Nike below it. So a really important point, it's an important sector. It's also very important to the coastal communities of Europe, a lot of whom have nothing else. At the turn of the century, our perception of the ocean and fish stocks was that the cod, the herring, the pilchard, the mackerel, and probably all the great sea fisheries are inexhaustible. My, how things have changed a century later. The need to change now has been driven by many policy drivers. Status quo is definitely not an option for us where we are now. The cumulative effects of human activities are leading to conflicts in the use of the ocean and to the deterioration in the marine environment that everyone depends on, not alone the fishing industry, but the climate of Europe depends on the state of the ocean. Against this background, and coupled to fleet overcapacity, overexploitation of fish stocks, and new developments in ocean management, we are at a major crossroads in our relationship with the ocean. There is a major train that has left the station and is coming down the tracks. There are new policy drivers in place which are all going to impact on the marine food chain and the way we do business with the ocean. The Maritime Policy, the Marine Strategy Framework Directive, the Ecosystem Approach, Birds and Habitats Directive, Data Collection, and the Common Fisheries Policy Review. In a sense, a lot of policy drivers coming together at the same time. I suppose the start of our food chain is the ocean surface, the zooplankton and the plankton that live there and get their starting point from the sun's energy. The fish that eat those plankton and zooplankton, the bigger fish that eat those fish, and ultimately the ecosystem where we have the sea with the animals and plants that live there. For far too long we have concentrated on just the fish stock and the ships that fish the fish stocks without paying attention to the wider ecosystem and the impacts fishing is having on that wider ecosystem. There are huge pressures on the seas and the oceans, and these are those, some of them, listed out by ICES. Climate change, eutrophication, harmful algal blooms, shipping, fishing, all are contributing to change the oceans as have done in the 20th century. I have a simplified marine food chain here, going from phytoplankton, zooplankton, fish, to marine mammals and birds and humans. And what I'm going to concentrate in the rest of my talk is how we have fished down that food chain and the evidence for that, the damage we have done to the ocean in a sense. Then the changes that are taking place in the ocean itself. And then I want to try and talk about how we may change our current management to deal with those challenges we have in terms of data needs, in terms of developing area-based management plans, and in terms of working with stakeholders. So my first comments on how we've changed the ocean, fishing down food chains. This is work that was done by Christensen, and if you look at what's happened over the 20th century, and the large predatory fish have been declining since 1900, and you can see in the 4 maps the decline in those large predatory fish. If you look at the trophic levels and how they've declined in the Northwest Atlantic and the Northeast Atlantic, basically what we have done is removed a lot of the top predators from our ecosystem and our food chains. If you looked at the shifting composition of the catch in the North Atlantic, on the left, 1950, on the right, 1998, you can see that we're taking much higher proportions of those middle trophic level fish, and we're taking far more invertebrates in the catch. So our catch composition has changed over time in the last 50 years. This is a very famous concept by Polly, which was introduced in 2003, fishing down the food chain. And he claimed we are sort of at the midpoint of this graph, where we have taken out all the large predatory fish, or much of them, and we're fishing further down the food chain. There was an interesting paper came out in November in Science by Branch and his colleagues, where they refuted this, and there's great scientific debate about this. He claims, and the paper, among other things, that we're actually fishing up the food chain. And if you think of fisheries in Thailand and the Far East, where they work down the food chain and work on mollusks and invertebrates, and then fish those out and move up, it's at odds with Polly's fishing down marine food webs. But I guess the point is not who's right and who's wrong, but that fishing is having an impact on marine food webs. If you look at the trophic pyramids in the Newfoundland and North Sea left and right, as they were at the start of the 20th century, and as they are coming into the late 20th century, you can see the number of levels in the pyramid has contracted, and the biomass represented by the size of the pyramid has also changed. So the point here is we are changing the ecosystem and the trophic levels. It could be climate, it is fishing activity as well, but it is human activity on the ocean that we think are causing these changes. Fishing down food chains. On the left, you see a food chain that involves saithe eating cod, cod eating haddock, whiting eating zooplankton and phytoplankton. And on the left, you see a much simpler food chain where it's just saithe, herring, zooplankton and plankton. And these are changes that Polly has identified, and he puts them down principally due to fishing activities. Another interesting observation in a paper by Sheffer in 2005, if you look at the Canadian cod collapse, which we're all very familiar with, and look at before the cod collapse on the left and after the cod collapse on the right, you can see cod and large predators, large biomasses, the smaller fish groups, smaller biomasses, larger biomasses of large zooplankton, smaller biomasses of phytoplankton, and then nitrate. After the cod collapse, cod have not recovered, but small fish and crabs and shrimp have exploded in terms of their biomass, and there are new fisheries there. So we have altered the ecosystem where, and the big question is, cod haven't come back, will they come back to this altered ecosystem? Another altering of the ecosystem has been with marine mammal abundance in the North Atlantic. And there you can see in the 1950s and the relationship to the 1900s. Another interesting piece of information which literally came out 2 days ago from a meeting in Aberdeen was the deep water and the results of trawl surveys. And what this shows you is the decline in the proportion of sharks as a component of the catch of trawl surveys. So in the early 1998s, when these trawl surveys were done, the percentage of big shark, top predators, in the catches of these surveys was far higher than it is today. Another example of us removing top predators from deep water food chains. So I guess the message from that is we have altered the ocean and we have altered the food chains and the food webs. Ocean changes have also taken place. If you look on the left, we all know about carbon dioxide increases. If you look on the right, a major thing that's happening to the ocean is a reduction in the pH of the ocean. And this is known in science, and this graph comes from the Interpanel on Climate Change. This is the graph of the chemical reactions that take place when the increased levels of carbon dioxide interact with the seawater, and the chemistry that takes place results in a reduction in the pH. The main point here is this has an impact on animals that use the calcium in the seawater for their shells, like phytoplankton, like corals. And corals are very important ecosystem, and it's not just the tropics that have corals. There are many cold water corals on the eastern borders of the EU. We all know about the temperature increases and climate change. And an interesting paper here in Science shows the distribution of plankton species on the top, 1958 to 81, the middle, 82 to 99, and the bottom, 2000 to 2002. And these are the results of continuous plankton recorders. And as you look across, you can see there have been shifts in plankton distributions over that time period. The result here will have impacts on juvenile fish and larvae on their food availability. So it will have big impacts. So now I'm into the area of how we can have better management. Data is one of the main components of this. At a recent fisheries data conference in Galway in 2010, there were 5 key questions asked at the end of the conference. Are the institutional frameworks that make use of fisheries data fossilised? They can't use new data or new techniques. Fishers are losing trust in fisheries advice and data. How do we regain this trust? Fisheries science needs to take up the data management issue. We need to emulate the data management capabilities of commercial companies. The holy grail is not stock assessment, it's sustainability. And how can we move from top-down management to co-management approach? And how can fisheries-dependent data better contribute to resource assessment management policy? And really importantly, how can the knowledge fishers have in their heads be used in the management process? VMS data is one of the really rich data sets that fisheries science and fisheries management have at their disposal. This is a picture of fishing activity off the west coast of Ireland. You can see the Irish fleet in green, Spanish fleet in yellow. And this gives you a very clear picture of where activity is taking place and to what extent. A very important part if we are to manage fisheries properly. If you divide it out, you can see on the top left Spanish fishing activity along the shelf edge, mainly for hake and megrim. If you look at the one on the right, French activity, mainly further inshore, the red hot spot down there is nephrops activity. If you look at Ireland fishing activity, you can see the red hotspots around the nephrops fishing ground. So what I'm making here is very important data we have, very important for future management because we can actually see what's going on. If you combine logbook with VMS data, you get very clear pictures of what's going on. This is where we combine VMS data and logbook data for the Irish fleet, and you can see where the blue whiting are being caught and in what densities. And you can see the same with cod in the south coast. You can see haddock and hake. Very clear picture of what's going on. Very useful to managers. We didn't have this data until very recently. A big problem that's undermining a lot of management and stock assessment and science is that landings data is still undermining scientific advice in that we do not know the true figures. And if you look at IC's advice and you look at many of the data quality issues, it is to do with poor landings data. Communications with stakeholders for better management. I think the RACs, the Regional Advisory Councils, have been a great success and need to evolve. They need to evolve and be used more in a new management framework. At the moment, there is stakeholder fatigue because of so many meetings and so many issues to deal with. Sometimes stakeholders feel that there's a box-ticking exercise been done in these consultations with the RACs. There is poor communications with the RACs on several issues, and I was amazed at a recent meeting how the RACs were not, and fishermen were not aware of the Marine Strategy Framework Directive and its implications on fishing. And one of the main frustrations about fishing industry and fishers is the amount of information they have in their head. We need to be able to capture that, use it in scientific advice, and bring it in to new management structures and regimes. We have a very complex system. We need to get that complexity and bring it down to simplicity so as people can understand the system and then work with the system. If a system is too complex, people don't understand it and find it difficult to work with. Picturing the data we use and telling a story is key, I think, to future management. This is an example of the vessel monitoring system we have around Ireland. The yellow dots represent Spanish fleet activity, the red dots British, the blue French and the green Irish. And this is millions and millions of lines of data, but it can be brought to life if you visualize it. And if I run it, it's in the form of a cartoon. The top is the date, 2007, and it's the 5th of January. And you can see the fishing activity that's going on. Again, very important to visualize what's going on in the fishing fleets if we're to manage what's going on, and very important to discuss with stakeholders what's going on and get them to input and tell the story. Area-based management plans for better management. A project I'm involved in talks about fisheries ecosystem plans, and it's based on the concept developed in the United States in 1999. We should contain and implement a management framework to control the harvests of marine resources on the basis of available information, not looking for consistently more and more information. Let's work with what we've got. regarding the structures and function of the ecosystem in which the harvest takes place. And we have a very simple model in this framework project called MFEPO. We evaluate the area we're talking about. It could be the northwestern waters of the RAC. What is the ecology, the socioeconomics, the ecosystem components of that area? And more importantly, what are our management objectives for this area? We consult with the stakeholders, we talk with them. What are useful and effective management measures we might implement? Then we make a decision, agree a fisheries ecosystem plan, agree objectives and management measures, and then we implement it, giving incentives and penalising to ensure compliance. And then we monitor, effectively monitor that, and then we review it and change, and it goes into a cycle. Yes, we will make mistakes at the start, but the key is we're working with what we've got. Also, this is a project that's in place and been funded. It would be very key to look at the results of this project and feed it into new management. The Marine Strategy Framework Directive has to achieve good environmental status, and fisheries cannot ignore that this is an environmental legislation and doesn't have any impacts on it. There are 4 major areas of the Marine Strategy Framework Directive which fisheries will have to take consideration of. Biological diversity is to be maintained. We can't continue harming food chains. Commercially exploited fish stocks must be in a healthy state. We must look after marine food webs, and we must look after seafloor integrity. They are only 4 key elements of the marine strategy, but they will impact future management of fisheries to a very large extent. So, meeting the new challenges for better management, some final thoughts. Sustainable fisheries through the ecosystem approach is key, and some suggestions on how we meet these challenges would be, we need to share data sets. What's very frustrating now for scientists is, like with the VMS data we have, member states will not share that VMS data because of the old thinking that it is our data, because it might show commercially sensitive information, and because it's very confidential. We can get around the confidentiality, but we need this data, we need to share it to implement better management. Communication with stakeholders. We need to have stakeholders more involved in assessing our management plans, in developing the management plans, and getting them to buy in to those management plans. If we do not have compliance for management plans, we will not have good, effective management plans. The application of research results. There are huge numbers of really good projects that have been undertaken. Lots of them gather dust on shelves and aren't used. We need to look at these research results, like the MFEPO project I was talking about, and bring them into new management. Area-based management plans. We have to get away from managing cod in an area to managing the area and the ecosystem, and ensure we have a healthy ecosystem to ensure healthy stocks, to ensure healthy fisheries. We need to embrace the need for change, and I was very glad to hear the Commissioner talk about her idea that this change in the common fisheries policy reform has to be deep-rooted, it has to be major. And we need to be practical and pragmatic with our management. We cannot wait till we have information on everything. We need to work with what we've got. Business as usual is not an option. Again, we are working a lot in our own little silos. Fisheries, environment, we need to break down those silos and work together. A clear take-home message, the need for scientists, managers, stakeholders and policymakers to break down sectoral barriers and work together and engaged in join-up thinking is greater than ever. And I think now we have a huge opportunity with all those policies drivers I talked about coming into being. And finally, food for thought. This was a quote from Charles A. Lindbergh, the famous aviator who died in 1974, but he was really into the oceans. And I think about him driving across in 1927 in the spirit of St. Louis, looking out over the great Atlantic. Our ideals, laws and customs should be based on the proposition that each generation in turn becomes the custodian rather than the absolute owner of our resources. And each generation has an obligation to pass this inheritance on to the future. To me, that is a beautiful definition of sustainability. In summary, what I hope I've given you is some background information on changes that have taken place in the trophic, in the food webs of the ocean, how changes are taking place in the ocean itself, how new management must rely on data, it must have more data made available, it must work with the data it has. Communicating with stakeholders, very important, much more engagement from stakeholders. They need to be given incentives and they need to buy into the management plans. Area-based management plans, move away from managing species, manage areas. And meeting these new challenges through data, communication with stakeholders and area-based management plans. Thank you for your attention.
Thank you very much, Paul, for that very interesting, very comprehensive and very focused contribution in relation to management. And of course, I'm sure everybody, or a number of people will want to ask questions, but I would suggest you would refrain from that until we have an opportunity to hear from our next speaker. And he is, of course, Serge Michael Garcia. He's chairman of the International Union for the Conservation of Nature, and he has been working with FAO for 28 years, and for the past 12 years or so he has been director of the Fishery Management Division. He's now chair of the Fisheries Export Group on the Commission of Ecosystem Management, and he's a member of the board of the, we're all familiar with it here in the Parliament, the European Bureau for Conservation and Development. He's also initiated ecosystem approach to fisheries, precautionary approach and governance. He's going to address us now this afternoon about the outcome of the international workshop organised in Nagoya in Japan prior to the CBD COP of the issue of selected fishing versus sustainable exploitation. Mr. Garcia, the floor is yours. Great contribution. Common sense language. Thank you.
Honourable Members of Parliament, ladies and gentlemen, good evening. Preserving the food chain for human and for the ecosystem well-being is a central challenge of modern fisheries management. World scientists have been struggling for decades to improve the knowledge and to propose solutions responding to the sectoral as well as the societal demands. The global adoption of the ecosystem approach to fisheries has added new demands on the scientific agenda and new constraints for the policymakers and the managers. In this presentation, I wish to draw your attention on the fact that the concept of selectivity, as it is currently transcribed in fishery management and conservation regulation of most countries, is more than half a century old. And it needs to be adapted to the new set of objectives and constraints stemming from the ecosystem approach. In particular, I will stress that based on a conventional species-based yield optimization approach to management, this concept of selectivity, as it is presently practiced, may not be able to fulfill the more general and fundamental objective of maintaining an ecosystem structure and function. The presentation I will make is based on the proceedings of a scientific workshop that was held in October recently, just before the 10th session of the CBD Conference of Parties in Nagoya, to which the results were then presented. The meeting met to discuss whether or not the conventional wisdom behind the present selectivity regulation worldwide was fully compatible with the ecosystem approach to fisheries and its objective of maintaining ecosystem biodiversity, structure, and functioning. The meeting involved 19 scientists from 12 countries, among the best available today. It was organized by the Fisheries Expert Group of the IUCN Commission on Ecosystem Management, with the coordination and the support of the European Bureau of Conservation and Development. The meeting was sponsored by IUCN, CBD, by EBCD as well, by the Census of Marine Life, and it received financial support from Norway, from a number of institutions in Japan, as well as IFREMER in France and DTU Aqua in Denmark. In this presentation, I will look at the selectivity concept. I will give you a series of reminders of what these things really are and what are we talking about. So something about the selectivity concept, something about the problems, a few of the problems behind the concept of selectivity and the way we operate it. I will mention something about new emerging issues regarding evolutionary problems. Then I will come back to the concept of food chain, and my task will be fairly easy because we had good presentation on the food chain before. Then I will present to you the results that were obtained by the participants at the meeting, on the one hand by using models, on the other hand by looking at real data. And then I will briefly look at the conclusions, and in particular the management implications of the findings if they are verified. A few statements that are agreeable by most people, I guess, is that first, the selectivity paradigm is a 50-year-old paradigm, and when it was elaborated, it was not ecosystemic. It talks about species, and it doesn't talk about relationship between species. And it ignores, therefore, the trophic relations and the predation in the system. The paradigm was to avoid catching juveniles and to avoid catching protected species. In the first case, to get higher yields, and in the second case, to make sure that they survive. More recently, there's been also calls to protect old, mature fish, particularly. I mean, the one that today tend to disappear. The issue of bycatch and discards are pretty hot. There is also an increasing concern raising about the fishery-induced evolution. The animals are changing, and they are changing because of fishing pressure in various directions, some of which are not very favorable to us. But the ecosystem approach to fisheries says that we should maintain the ecosystem structure and its process. But on the other hand, we know that any selective removal from the ocean will change the population, and it will change the community in a way that is not intuitive at all. Hence, uncoordinated selectivity regulations may diminish rather than enhance the sustainability of the fisheries system. Are we sure that we are doing the right thing? And the conclusion of that slide is only that the selectivity paradigm really needs to be reassessed in an ecosystem perspective. And this is what this working group has tried to do. Some of the key questions are, for instance, are the present practices making things better or worse for the ecosystem? Could selectivity be optimized at population as well as at ecosystem level? And could selective harvest and selective protection be co-optimized? Now, let's look at the selectivity concept. The definition of selectivity is that it is a process through which fishing obtains a catch which composition, in terms of size, sex, or species, differs from that of the natural habitat. So selectivity makes the difference between what is a system and what you have in your boat. It is also the probability of a species, or a sex, or a size, or an age to be caught. Now, it results from an appropriate selection of the fishing area, the fishing depth, the fishing season, the fishing time, day or night, and the fishing gear, and not only the mesh size of the gear, but the way it's mounted, the way it's used, etc. So selectivity is a very complex outcome of a lot of selectivity operations. It is conventionally regulated for, one, maximizing the long-term yield we obtain from each new young fish that enters into the fishery, and I'm talking only about the target species, and to reduce the catch of unwanted or protected species. But selectivity in reality is used by fishers to maximize their short-term economic returns. So on the one hand, we have a biological reason for putting selectivity, but it is used by people that are looking for money, not budget, and I'm not criticizing that, that's their life. Now, conventional selectivity regulations ignore trophic relations and predation. I've mentioned that before. So what is the impact? For instance, an example I have here is a well-known example on cod. There were discussions about changing the mesh size from 85 millimeter to 120 millimeter. And on the right, in orange, you see the calculations of that impact, considering that cod is alone on the ocean, not eating anything, and not being eaten by anything. And the results appear positive for all the species that are caught with cod and around cod. Then scientists did the calculations again, putting predation in. And the result is that changing that mesh size would be negative for all the species, not only for cod, that is target species, but all of the species living around it. What that tells you is that as soon as you put predation, cannibalism, and the food chain in the picture, then a lot of our conventional calculations on selectivity are not warranted anymore. In fact, one of the participants at the meeting in Nagoya, when he came back home, went back and checked what has happened really in that system since 2001. And his result, he found, is that it's neither what is on the left of the picture nor what is on the right. The system just did something else. This, in a way, should tell us how difficult it is in a complex ecosystem and in a complex food chain to predict the consequences of the measures we take. Another example is on the place and sole fishery. You have there an evolution of the biomass until 1985. Then the scientists decided to do something to protect that stock because a lot of juveniles were being killed instead of passing through the mesh. And therefore, in order to protect them, what they call the place box was put in place. A large area of the coast was prohibited to fishing. The idea was the juveniles were going to be protected and the stocks were going to grow up. What happened is that, in fact, the stock went down. Now, why did the stock went down when all the juvenile plays were protected? Well, simply because the juvenile plays had decided to get out of the box. So they had been in that box for 20 years or 30 years. But by coincidence, as soon as that box was protected, they moved out. And so they were not protected at all. Now, the even ironic thing is that, again, we didn't control nature, and we didn't control where the juveniles were going to gather. The ironic thing is that that fishery indeed did better. You know why? Because the fuel cost took out a number of vessels from the fishery. This is another example with selectivity, which is the work that has been done, fantastic work done in the East and Central Pacific to protect dolphins in the tuna fisheries. Before the protecting measures were put in, the tuna caught was, the weight of the tuna on average was between 18 and 22 kilos. The quantity of animals discarded by set was 0.1 ton. And the bycatch was about 1 dolphin, 0.3 sailfish, and 0.2 manta ray per set. Measures of protection were put in there, and in fact the mortality of dolphins went down from 100,000 dolphins killed per year to about 1,000 and something. So a very successful program of protection of the dolphin. The problem is that the fishery has adapted to that change. And what happens is now you have fisheries in which the size of the tuna fish is only 3 to 6 kilos, the number of fish, the quantity discarded per set is 4.6 kilos, and the bycatch rate is now 26 sharks, 1.8 marlins, 800 large bony fish, 1,200 and 50 small fish, etc. The main reason is the fish has turned into a fish-attracting device fishery. It has changed strategy, and so the consequence is not the direct consequence of the measure. It's a direct consequence of the measure plus the reaction of the fishery system itself that leads to a consequence that certainly was not expected when the measure was taken. An issue more recently emerging is that of selective forcing of the genetic pool of the animal. The curve you have there in yellow is what is the natural mortality of these animals. When they are young, they have a high level of mortality, and when they are old, the level of mortality goes down. The green curve is what fishing does. Fishing impacts very little on the young fish, but a lot on the large fish. So what is really happening is that the pressure imposed on the fish by fishery is completely opposite to the pressure that life imposes to it. And in fact, if you think about large cods, it is not good anymore these days to be a large cod. It would be better to be a small cod. And of course, it's not surprising that in fact, what we see, for instance, in that curve here, the red line is where the fish were before we started fishing them heavily, in terms of age and size at maturity. And you see that most of the fish are now maturing much earlier and at a smaller size than before. They are trying to become small because it doesn't pay to be big these days. An example here is the Arctic cod, where you see the I think it's the age at maturity or size at maturity, I'm not sure, that has been going on for many, many, many years. In fact, the work done on this issue shows that what happens is a selection of new phenotypes, smaller fish that Matthew earlier has selected. The maximum body size goes down. We see an increase in reproductive investment. The animal starts reproducing earlier and more. But we see also, as a consequence, a better resistance to high level of fishing. Of course, the animal is trying to resist to a high level of fishing. But we see also a decreased resilience to the environment, a reduction in the resource productivity, a reduction in the number of subpopulation, and a reduced genetic variability. In conclusion, I would just say a few things, like conventional regulation of selectivity has met with a mixed bag of results, some positive and many not really positive. That the single species paradigm replacement is probably overdue, and that also that predicting multi-species and ecosystem effects of selection is not very easy, and that genetic and phenotype forcing is an additional emerging concern. There is no clear evidence, in fact, today, that the conventional selectivity regulation we have been doing for many decades complies with the EAF requirement to maintain an ecosystem structure and its properties. The conventional selectivity paradigm, therefore, would need to be revisited. I would just say a few things now to remind you of a few ecological notions. When you see this image, the question is, which of these two fish are more similar? You have a large cod, a small cod, and a much smaller fish below. The normal classical response for the species-based approach is that the two cods are similar, the large cod and the small one. But an ecological approach is that the two animals really similar are the two small fish because they belong to the same trophic level in the food chain and their fate is connected. Another element I want to mention also is that this is a life cycle of an animal, of a fish, for instance, the cod, as it grows from eggs to a big adult. These animals reproduce, but what I want to stress is as they move through their life cycle, they in fact change trophic level. They are part of trophic level 1 when they are eggs, and they are part of trophic level 4 when they are adult top predators. The point here is that when some people classify cod as top predators and anchovies as prey, we are making a big mistake because all of these animals tend to be predator and prey at a certain moment of their life. So we are making approximations. The food chain was already described before, and I will just remind you of what people call trophic cascades because they are important in the end of my talk. As was said before, that trophic chain is controlled from the top by predators and it's controlled from the bottom by the environment. You can hardly see the arrows there, but the first example is, of course, when the prey increase, predators, intermediate predators increase, and top predators increase. Now, that was said before. What was not said is that if top predators increased, you would have a wave of feedback going down, because if the top predators increase, well, then they will decrease the abundance of intermediate predators, and the abundance of the intermediate predators go down, then the prey will go up. Similarly, if fishermen fish down top predators, the intermediate predators will increase, and the abundance of prey will go down. Now, these things are very, very simplified, but the point is only that whatever you do on the food chain, at the bottom of it or the top of it, it creates a chain of events that will start bouncing up and down into the system until it stabilizes, hopefully. And therefore, any positive or negative change will have a series of consequences. Now, let's look at the trophic pyramid in this way. We have four trophic levels. The problem of harvest is the following, and this was mentioned long ago. The best way to exploit a trophic chain would be to extract a sort of proportional part of it. Proportional to what? Well, proportional to its natural productivity. That would be the thing to do. So what we would like to have is a catch that has a composition similar to the ecosystem, and the ecosystem keeps its structure. Now, you cannot see the definition. The way to do that would be what we call the meeting called balanced harvesting. And the definition was that balanced harvesting is a fishing strategy that maintains the ecosystem structure by keeping fishing pressure moderate and distributing it across ecosystem components, that is, species, sizes, and trophic levels, in proportion to their productivity. Now, the question is, of course, can't read the red either. How could this be proven scientifically? How can this be achieved, and how can it be controlled? Many models were used by the members of this working group to produce a result that they brought after the meeting. One model that was used was, for instance, this one. If you take the world ocean and you take all the particles that live in that ocean, the living particles of all the sizes, and if you drop them into baskets which are put in logarithmic order, then you obtain this, which is a linear relationship between the log and their abundance and the various categories of size. Now, it's quite interesting because we've seen before how complicated an ecosystem is, but if you turn it into this model, then the structure of the ecosystem is a straight line, more or less straight, of course, in reality, and one can start looking whether this straight line goes up or down, or if its slope changes when you fish the system, and then you can draw conclusions. Along this line, the same phenomena happen that we discussed before in the trophic chains. The big fish on the right hand go up the line to eat the small fish, which are on the other hand, and the small fish are trying to grow desperately to become big. And in between, you have equilibria. When you start impacting one end of this line, taking out large fish, or adding small fish, or taking out small fish, then a wave goes into the line to distort it. And that can be observed in dynamic modeling. This result there was a different one presented by an Australian team. They used a large number of ecosystem models, all sorts that were available on the literature, and they studied 25 or more ecosystems. And then they simulated different conditions for fishing. And what they did was simulate cases in which fishing was taken only a few sizes of a few species, so focusing heavily on a few things in the ecosystem, and then they simulated a much broadly distributed fishing, catching a wider range of species and a wider range of sizes. And what you see there is, for instance, this red line here is the way the number of collapsed species grows with time, or with exploitation rate. You see this line of collapse goes up quite rapidly. If you look at when the fishery is more distributed, it goes up less rapidly. If you look at the biomass, it goes down very rapidly on the left, much less rapidly on the right. And if you look at catch, the catch tend to go up rapidly and collapse also very rapidly in the left, while on the right, the catch continues to go up very far before it starts collapsing. In brief, what these two graphs show is that when you look at the medium exploitation rate, so when fisheries are not close to virgin or heavily overfished, but when they are normally exploited, right in the middle, the situation is easier to manage on the right with a widely distributed fishing effort than it is on the left where the fishing effort is heavily concentrated. The group also looked at empirical evidence because all of this are conclusions that were given by mathematical models. And although the mathematical models tend to concur in their conclusions, of course it would be good to have empirical evidence that this is correct. It was very hard to find empirical evidence. For instance, tests were done on two large ecosystems on the North Sea and on the Georges Bank, and it couldn't be proven that the effect of fishing pattern, that effect of the fishing pattern on the ecosystem structure. The only evidence that came very close to showing stability in the ecosystem structure were a series of examples coming from inland small-scale fisheries of Africa, in which management is not supposed to be very effective. The gears are extremely numerous, the fishing strategies also, heavily exploiting a system, still maintaining its structure. In contrast with that, there is work done in the North Sea and the North Atlantic in the ambit of the ICES institution that show, on the contrary, that when you look at our industrial fisheries, that slope has changed. The intercept has changed and the slope has changed as fishing has increased. Now, the tentative conclusions of this work is as follows. First, that all conclusions are provisional, because most of them are model-based, not based on real life information. There is a fact, and that is that there are robust relations between the individual size and the abundance. And this relation can be studied to understand the reaction of the ecosystem and and fishery management strategies. Generally, the models support the intuition that the scientists had that the concentration of fishing on a very narrow selection of species or sizes in a species assemblage may not be the most sustainable way to use an ecosystem and to maintain its properties and its processes. We have been used to think that being very selective is better. The models say that that may not be correct. Now, the models show also that spreading fishing pressure on the species and the size spectrum appears theoretically preferable for the ecosystem stability and often also for yield. At population level, it has been shown only by one work, so it has to be verified, that if we reduce the pressure on the juvenile, the very small fish, and we reduce the pressure on the old fish, that may help stabilize the ecosystem structure, and it tends to reduce also the genetic drift. On the contrary, it has been shown also by modeling that the depletion of the large size, so the depletion of all spawners, could have in fact a destabilizing impact on the ecosystem structure and on the species relationship. I have said that it has been impossible to verify empirically these effects, but there are some apparent examples of sustainable ecosystem structure despite widespread fishing pressure. It is not yet clear, it wasn't clear to the working group how the conclusions on the ecosystem and the assemblages and the conclusions on the population could be combined. It is interesting anyway to look at the management implications of those findings. Obviously, the target for management is how to slice the pyramid. We have an ecosystem. How much can we take of every step? The suggestion of the group is that first strategies to do that should be built around the idea of cumulative selectivity. We are not interested by the selectivity of one gear or of one vessel or of one fleet. We are interested by the overall selectivity of all those fleets operating together on the ecosystem. What is happening? Another comment is that we should evaluate the performance of the strategies already in place. At the moment, on large ecosystems, we have a lot of selectivity strategies in place. They all have been designed separately. All have been designed without any connection with the rest of the ecosystem. So altogether, if you pile them up, what is the total effect of these selectivity strategies on the ecosystem? If we need to balance an ecosystem, is it in relation to what? The trophic levels, or the sizes, or the species assemblages? Now, the selection toolbox was not discussed very much because we are convinced that we need to use all the tools we have. We need to use selectivity on gear, time and areas, market controls, fishing rights, ecosystem taxes, incentives, eco-labeling, and also novel food technology to make sure that the species we don't like today, maybe we should use properly. It was also mentioned that the management strategy in any case will depend on the starting point. Are we in an ecologically disastrous situation or in economically poor or socially very poor situation? This will have impact on how the strategy will develop. It will also depend whether we talk about large-scale or small-scale fisheries and whether we are in the high seas or in the EEZ, obviously. And one point was made also is that it will be necessary to discuss selectivity of use and selectivity of protection together. At the moment, these debates are in two different streams of governance which do not have a lot of convergence yet. And it was also mentioned that the role of NPAs and reserves as reference areas should not be forgotten. It was mentioned also that there is a need to shift from single species regulations to regulation of assemblages and on ecosystem-based regulations. that maybe we could start thinking about increasing the focus on diversity and diversification of harvest, and on better distributing the impact across species and sizes, while also protecting juveniles and spawners. These are not recommendations, they are suggestions that stem out of the conclusions. It was also mentioned many times that we need to reduce the overall impact by eliminating overfishing as a prerequisite for implementing and benefiting from balanced harvest. It's very hard to talk about balanced harvest on a system that is totally unbalanced today. And in fact, one of the questions is how can we rebalance the system, and can we in fact rebalance completely a system? A side comment of interest was that it would be interesting to look for alternatives to the modern increasing species-based segmentation of fishing rights. The modern management about fishing rights is in fact segmenting the capture process more and more. How does the sum of all these things look in terms of balancing harvest on the ecosystem? We should be looking for balancing these things more across a wider spectrum of species and sizes. It was mentioned that incentives could be used to convince fishers to broaden the scope of harvest when appropriate. For instance, when some species are just too low a price to be worth taking. My own graphical interpretation, and this is really personal because we didn't go that far, was that on the left we have the sort of picture we had before. Fishing pressure was concentrated on large sizes of large species. And what balanced fishing would mean is a lower fishing pressure overall, and then a better distribution across all sizes and species, probably protecting the small juveniles and the very old spawners. The urgent thing at the end, if there is only one thing to think about, is to start aiming at a correct ecosystem structure and think in terms of management, think about management in terms of the effect on the structure and not anymore or not only on the effect of abundance, which is the only or main problem today. Thank you for your attention.
Thank you very much, Mr. Garcia, for a very interesting presentation on the outcome of the international workshop organized in Nagoya in Japan. And of course, while it's difficult to absorb all of what you say, I was very impressed at the use of the layman's language and not necessarily scientific language, because all of this is not about scientists. All of this is about all of the stakeholders in the sector who have to fully understand the importance of ensuring that we have a sustainable fishery, because we are only the custodians. We have a role to play in order to ensure that future generations can benefit from this. And it brings me to the very last point, is the balanced harvesting, and if we can concentrate on that. But the whole idea of the outlining the selectivity concept, the selectivity problem, the evolutionary problem, the food chain concept, the modelling, the empirical evidence, the tentative conclusions, and of course you said something similar to what Paul Connolly said in a different way, was working together to discussing the use and protection strategies, but doing this together. So we'll have an opportunity in a minute to ask either Mr. Garcia or Paul Connolly questions, but just to recap on Paul's presentation was how to meet the challenges, and he elaborated on sharing data, the importance of communications with the stakeholders, and that issue was raised with the Commissioner when we met with her yesterday. I believe there has to be communications with the stakeholders. The stakeholders have a major role to play in providing data which the scientists can take on board. The whole idea of the area-based management plans. The other point that he made was to embrace the need for change, and of course the practical and pragmatic, to be practical and pragmatic with management, to break down the barriers, to work together. And that was a common theme in what Paul's presentation was, and the final contribution by Mr. Garcia. So I now open the floor to questions, and perhaps you might indicate with your name and the organisation that you represent. did say it was all in layman's language, and perhaps, oh yeah, can I have...
Thank you. I have a question, but it's probably more a comment. My question is science ready to give advice to management on an ecosystem approach, or even, as Paul mentioned, an area approach, for example, for long-term management plans? And if not, how do we go from here? Because my guess is that science, at least is not ready in the short term. It might be in the medium and long term. And if this is the case, then how do we go to making changes in laws and, for example, changing species regulations to ecosystem regulations? And my personal opinion is that I think that the management, at least in Europe, should be in a flexible way that allows for adaptability, for changes in environment, but also in the knowledge that might come about in the near future. So my perspective is that the reform of the common fisheries policy should take a more global view or a global objective of ecosystem, but should keep some of the operational objectives, as I call it personally, regarding, for example, MSY, bycatch management, technical measures, etc. And I would like to see the views of the speakers. My name is Lisa Borges, and I work for the Sustainable Fisheries Partnership. Thank you.
Thank you for your question, stroke comment, and I'll pass it to Paul for a response.
I'll give you a response to that question. You've actually hit the nail right on the head. But I would say in response that any change process, that same argument is always brought up. No matter what you're changing, we're not ready for the change. How can the existing structures we have in place cope with that change? And I'll go back to when I led the change at ICES to reform the advice. The same arguments were brought up. We're not ready for it. We don't have all the answers. You never will have all the answers, but I think you've got to buy into the change and go for it. The second point I'd make, there was an ICES dialogue meeting in Dublin 4 or 5 years ago, and it dealt with the whole, how do we implement the ecosystem approach? And one of the conclusions out of it was, you don't have a revolution, you have an evolution of what you've got. And the other point that was made was, we will take baby steps towards that, the first small steps towards it. And I think there are plenty examples that we can use for area-based management. I'm involved in a project myself where we're looking at the Celtic Seas, where we're working at stakeholders. No, we don't have all the answers, but I think we can move in the direction of implementing area-based management, working with stakeholders, but we have to sort of take on that we will make mistakes, we don't have all the answers, but if there's a commitment to move in that direction, I think we'll get the answers as we move. But if we wait till we have all the answers, we'll be sitting here talking about it with the next reform of the Common Fisheries Policy.
Thank you very much, Paul. Sorry, Mr. Garcia.
Thank you, Mr. Gallagher. I could add a few things. Is science ready to give advice? My response is yes, and I think we agree with that with Paul Connolly. Is yes. My experience is not with the North Sea or with European areas, is with Africa and small countries and Cyprus and things like that. And science is ready in many ways because everything we need as instruments is there. I mean, for instance, there in the sense of theory, not always implemented. But for instance, integrated assessment was mentioned before. FAO has done a lot of work on integrated assessment and advice, saying you cannot do the assessment on one part and then have the advice done somewhere else and the political decisions done elsewhere. You have to have an integrated process of which the people are part. This is done in small-scale fisheries. It's done by rural economists or rural foresters. It's just not done in fisheries yet. And of course, it's complicated in an international environment. But it is feasible. You can do easily integrated assessment and advice, even if the problem is complicated, even if you don't have all the data, because all the stakeholders are together in that process and they take decisions together. This is the result is more legitimate, the result is more effective in a socioeconomic sense. Will it be more accurate than if we had 25 years of science? Probably not, I don't know. But if you adopt also at the same time an adaptive management, so you have the possibility to make trial and error, etc., that is a way to go. We also have another instrument, risk assessment. Obviously, we have to stop pretending that we can predict what the mesh size does and stop predicting what the stock size will be in 3 years from now. We know that we don't know. So we don't know at least as exactly as everybody would like to know. But we know a lot, and we know enough to do this assessment in terms of risk. How risky is it to make that decision? And if the stakeholders are willing to take that risk, you can go ahead. And risk assessment and risk management is something that exists. There are manuals around. They've been around for 35 years. We just don't use them yet in fisheries. The precautionary approach is there to give edges to the amount of risk we can be allowed by society to take. And that's it. So in my view, and we have shown in poor countries in Africa that that approach can be applied. Of course, it's easy to apply in a small community in a small bay. It's very complicated to apply at the level of the North Atlantic. But the instruments are there. The question is to adapt them and implement them.
Thank you very much, Mr. Garcia. Now I'll give the floor to Dr. Neuenfeld.
Actually, I don't have that much to add to what Dr. Garcia was saying. I agree. On the other hand, it is of course clear that let me tell you the story. When I've been at the Baltic Sea Regional Advisory Committee, and I was posed with the question, what do we do to get a healthy ecosystem? And that is something like demanding a light-speed airplane or something. Science is not geared to develop healthy ecosystems, but it is to a large extent a normative question, because what is healthy? I mean, the question we have to pose is, what do we want? What do we want in terms of the socioeconomic impacts of fisheries, but especially thinking about the following generations, how do we feed 9 billion people? Is feeding 9 billion people more important than maintaining the whales? That's very provocative, but this will be questions we are posed with. So I absolutely agree that it is time to start now, and that science right now is not able to finish the business, but it is able to start. And we also have to, because it is about time, keeping in mind that the status quo is not even a multi-species oriented management. It is still most of it single species.
Yeah, and I give the floor to Dr. Neuenfeld.
Yeah, thank you very much, Mr. Chairman. Yeah, as you posed the question to all of us, I think I'm also would like to give an answer to you. Actually, I think, yes, I fully agree with most of my four speakers. We are geared to give advice for the ecosystem approach. The reason why I think that actually is that the ecosystem approach will not come along as one package which you just turn on and then it functions and it goes. It will be coming along as tiny bits and pieces. And I think it's very important that the policy is really geared to take in these tiny bits and pieces whenever they are ready to be implemented. And for quite a number of different steps, science is well in shape to give advice. We are well in shape to give advice on single stocks. We are partly well in shape to give advice on multi-species issues. We are also looking into how fishery really behaves using the VMS data that was mentioned before. We're having different projects on discard. We're having projects on fully documented fisheries ongoing. So we really have a lot to say and to help really to advise policy. But I think we have to abuse the picture that the ecosystem approach will really come along as one single package. And that is the most important message, I think.
Thank you very much. Are there any other questions? Sure, okay.
Second one. My name is Nuno Campo. I work in the European Parliament. I'm assistant and advising Ms. Patrão Neves for the Fisheries Committee. And I would like to take this chance just to put you a question. Concretely to the southern egg. This is like something that came up to my mind after listening to all of this. As you know, this species is within a recovery plan. And the research and the data collected just showed that the biomass was increasing recently. What happens now is that there is an increase of the TAC and there is a reduction of the fishing effort. So it means that fishermen will fish in a more concentrated way. And I'd like to know your comments about this. Is this a paradox? Is this silly? Or is this a good way of manage fisheries?
Okay, who's going to take that? Any volunteers? Now, don't leave it to a humble MEP like me to have to take a question that you eminent scientists. Dr. Garcia.
I would just say that it's impossible to respond like this. One would have to have all the data on who lives around that Hague, was it? Yeah. Southern Hague.
It's exactly as Serge says. You need the full story. You need to look at the data. You need to look at the advice, and then without that, it's impossible to comment. So I wouldn't risk giving the wrong comments, but really to answer that question, you need the detail of the stock and how the advice was generated and basically the parameters of the stocks. So I would not like to comment on it, just with that limited bit of information.
Well, the thing is that the conclusion was that the biomass increased. This is one point. According to this, they increased the TAC, but they decreased the fishing effort. So
If there aren't, I will draw this session 2, to a close and thank our two speakers, Dr. Paul Connolly and Dr. Sergio Garcia, and also in the previous session on exploring the reasons for imbalances, Dr. Neuenfeld and Dr. Kraus, to thank them, because I do believe that the fortunate people in Parliament today are the people who attended this conference. And I must say that I'm pleased with the turnout, bearing in mind that this is the week when we have our group meetings, and it can be very difficult. So to all of you who attended, those who are here on behalf of MEPs, the assistants, those who are representing other organisations, we're extremely grateful to you for attending. And the papers and the presentations by the four eminent speakers, as a matter for them, if they so wish, perhaps they would let Vicky in Brita's office or Eamon in my office have them, and anyone who's interested, or perhaps you can get them directly from themselves. But I'm certainly very anxious. And what impressed me most of all, that normally, and I say this with the greatest respect, I wasn't great at science at college, but it was a pleasure to listen to you, because I think if more people and scientists, with all due respects to some scientists, if they spoke in layman's language that we can understand, because there are times it's way above the head of most people. And that's what impressed me most. And I want to thank you very much for your contributions. I want to thank Britta Reimers for her initiative. I was very much very in the background, having to do very little, but it was her initiative, and I was delighted to be associated with this. And in thanking Britta, I want to thank Vicky and her office for her support, to thank Eamon, my own office, and of course one who is here a long time, but you wouldn't think that to look at her. Despana, she's here. I was here in '94, and she was here some years before that, and she is very, very knowledgeable, and she works with us and works with all the fishery groups, and I want to thank her, and also Kathleen, who works with her. And of course our own policy advisor that we cannot do without, Diana. I want to thank you as well for your support in all working together. It's another togetherness, all working together to make this conference such an outstanding success. And I want, in conclusion, to any of you who may be hungry, that the reception is ready. And I suppose, as a sign of the times, we have to lead from the top. There is no alcoholic drinks. And of course, it's in a recessionary Europe, and I think we have to start from the top. Now, I'm not so sure whether that's a good excuse for not having a big budget or not, but I would ask you to accept it as. So, I was told, I read it as non-alcoholic, but there are alcoholic drinks. There are also beer, and for some of us, there are non-alcoholic drinks.
Recession's over.
So it was a very short recession. I want to also, and in conclusion, because there were a lot of scientific words used here today, I want to thank the interpreters for their contribution to this conference, because without them, we certainly couldn't operate. So in conclusion, let's remember that all of us are only the custodians, and any fishing should be done. It should be exploited, of course. It should be done in a sustainable way with a view to ensuring that fisheries will be there for future generations. And in fact, the more that we have within Europe, the less imports into Europe. So thank you very much, and enjoy the rest of your short stay here in the European Parliament. Thank you.